Hello. Today we want to talk about one of the features in PowerFactory, generation adequacy analysis. So sometimes we have some renewable generation technologies, something like wind turbine or PVs. And as you know, for example, if we have wind turbine, it's working with the wind speed. So if we have different wind speed, for sure we will have different output values. And we should check that, okay, if we have one load that is connected to that wind turbine, in how many of the situations, with how many chance or likelihood, we can keep the connection to that load. So it's somehow a statistic or probability analysis for renewable energy generations. So for this reason, we just installed one wind turbine to a bus bar, 10 kilowatt bus bar, and the wind turbine can be found from these um, uh, drawing tools. Just another one line without any specific values, just 10 kilovolt to keep the load flow running, and here is 10. And the load that we connected is 0.5 megawatt. And the wind capacity is 1 MW, so it's twice of this load. So if this wind turbine is working with 1 per unit, so it can easily inject power to this one, because this one is 1 MW and this one is 1 megawatt, so 0.5 megawatt, and easily they can inject the power. So if you double click on the wind turbine, here we have the generation adequacy. Normally, this is a thing that you can see. The wind model is off, and if the wind model is off, there is no uh, statistic analysis. Check this, and here it's not necessary to change anything on statistic model. Wind model is variable distribution, is some normal distribution, and we can just keep everything same here, but here we should add the wind power curve. So if we don't choose this one, and if we want to click OK, there is an error. So this part is somehow is mandatory. We can click on this and new project, and here we have wind power curve. So this is wind power curve. Here is a speed in meter per second, and here is power in per unit. Just right click here. We can append, for example, I don't know, 9 rows. And here we can put some numbers, for example, 0, 2, 4, 6, 8, 10, 12, 15, 20, and maybe one more. 2, 4, 6, 8, 10, 12, 15, 20, and 30. Okay. So we assume that everything is completely constant. So with any wind speed, we assume that we producing 1 per unit. Click OK and OK. So always this one is producing 1 per unit, and this is 0.5 megawatt. So easily it can consume the power. So here, if we click on generation adequacy analysis, here we have initial condition calculation, execute. Then here we can run the analysis for how many iterations is one in 10,000 different cases. Execute. And here we have 3 different plots. The first one is distribution plot. If you click on this, so here you can see on top left, you can see this is the total demand is 0.5, and this is total available capacity is 0.8, because it was 1 MW with 0.8 power factor. So we can see easily it can inject the power. If we make a Monte Carlo analysis, easily we can see the chance for loss of load is 0. So here, this is the third one is loss of load chance. So we can see the chance is exactly 0. But if we back and make it more realistic here, so it cannot be true. So here is normally 0, here is normally 0, here it can be 0. Just some numbers to make it more realistic. And the last one should be 0 because we have some breaking. So here we have different methods for making this curve. This is a constant value that we use, or linear is the best, so it's more realistic. Click OK, and now click OK. Now we can make the simulation again, and okay. Now if we back, we can see that here is the in 100% of cases, you can see after 34% of the cases, we cannot consume the power. So the wind power generation become lower than the demand. So now if we make Monte Carlo and also loss of load probability, we can see that here easily. If we make Monte Carlo again, so here you can see here we have 10,000 different cases, and you can see more or less we have 3 different cases: loss of load probability, average, lower, and upper. So it's more or less same. So you can see most of the cases we have loss of load probability. So this is the chance for cannot injecting power to the load. So for example, if I increasing this one to 5, for example, now we can, if you can see here, it was 34%, now it's 70%. So on 70% of the cases, we can inject the power. That cases is for the power, for the time that we don't have the wind speed, enough wind speed.